You may have heard that Earth's magnetic poles tend to move around. I mean, so do the geographic poles, but magnetic north and south are really mobile. And magnetic north in particular is moving real fast, like way faster than we thought it would. And the scientific community is coming up with some really exciting and creative ways to figure out why. The prevailing theory about why our planet has a magnetic field in the first place is because of what's under the crust. Dynamo Theory, as it's called, is the idea that the molten metals of the outer core, like iron, are being convected, basically swirled, all around the Earth's interior, around that solid inner core. This continuously creates electric currents as charged particles move through this liquid metal, and in combination with the rotation of the Earth, it becomes what's called a dynamo, the source of a magnetic field. This also explains why the magnetic poles are not necessarily fixed points, because the liquid that creates that magnetic field is turbulent and always shifting, and the poles move as the fluid does. Right now, for instance, the North Magnetic Pole has been slipping down into Siberia for the past 150 years or so, and it's speeding up. Our magnetic field actually has a name. It's called the Magnetosphere, and it plays a crucial role in making Earth a habitable planet. It wards off much of space's harmful radiation, like cosmic rays, acting like an essential protective cloak around the Earth, which is one reason why scientists and governments are so invested in knowing how it works and how it will behave, like the World Magnetic Model, for example. This huge and innovative computer model of Earth's magnetic field behavior is used by many international bodies as the guiding standard on what the world's magnetic field is up to. It combines sensor measurements of the field's strength and position, measurements which are then used in simulations of the geodynamo's past, present, and future behavior. The WMM releases updates to the model every 5 years, but in 2019 it was forced to release a mid-cycle update because magnetic north has been sauntering vaguely downwards much faster than anticipated. The perfect example of the fact that even though we're measuring and predicting to the best of our abilities, the geodynamo is too unpredictable and complex to make a truly complete model of it. That uncertainty means scientists are also looking for experimental ways to further probe the Earth's magnetic behavior, which typically involves creating models of the Earth out of liquid sodium, which is quite the commitment because sodium is a highly reactive metal that is extremely difficult to handle and likes to spontaneously burst into flame. New sodium ball experiments are being used in several labs worldwide, and in combination with improvements in computing and machine learning, could help us gain more insight into how Earth's magnetic field will change and how we can prepare for it when it does. Because what does a shifting magnetic field actually mean for us? Flipped poles would mean that the names of Earth's hemispheres may be a bit confused for a while, and compasses would point in the opposite direction than they did previously. But more importantly, as the poles shift around, the magnetosphere could get weaker, with several smaller magnetic poles popping up in other places around Earth. A weakened magnetosphere means many things. The northern lights will be visible in new parts of the world, for a start, and all our satellites would need to be extra fortified against radiation, or we risk them getting totally fried by space weather like solar wind. Electronics here on Earth would be extremely vulnerable to interference and destruction by space radiation too, like our power grids. And that's not even mentioning the human health effects of being exposed to much higher degrees of radiation from space, which, let me tell you, are not great. We know from studying magnetic inclusions that Earth's magnetic field has flipped entirely in the past. They trade places about every 300,000 years or so, but it's been over double that amount of time since the last time we know they flipped. So we are long overdue for some magnetic migration, and it's happening fast. And scientists are working hard to understand why and how they move and what exactly it may mean for us when they do. The next update to the WMM is expected in early 2020. Do you want to know more about it when it comes out? Let us know down in the comments below. And as always, thanks for watching, and we'll see you next time.